Lots of students are coming into career counseling centers like this one to find out about working in computers. Well, what really are the job opportunities in the field, and what kinds of skills do you need to get them? We'll get answers to those questions today as we take a look at careers in computing on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and this is Gary Kildall. Gary, we're hooked up here to something called the Online Career Network, a kind of electronic help wanted ads for computer jobs, and we see right now a listing of job opportunities in the fields of fiber optics, semiconductors, personal computers, computer-aided design, robotics, and new computer architecture. We're talking about job opportunities in this field now, and it's kind of confusing. One day you read in the paper that some computer company has laid off 500 people, and the next day you read in the paper that there are all kinds of job opportunities in the computer field. Now, which is it?
Well, Stuart, the personal computer industry is still young and quite volatile. If you want stability in a job, you move up toward the mainframes, where a bright engineer with a well-rounded education, say mathematics, computer science, always find long-term employment. Now, career planning in the new emerging area is more difficult, but if you're adventurous, you'll also find it's a lot more fun.
Well, we're going to take a look at what the job opportunities are in the computer field today. We'll meet high-tech placement counselors, recruiters, and employers, and we'll try to find out what it's really like to work in computers. Now, one of the nice things about the computer field, as you know, Gary, is it doesn't only provide employment opportunities, but entrepreneurial opportunities. So we're going to start out by taking a look at the self-employment possibilities in the computer field.
Somewhere between the stodgy giants and the fragile startups of the computer industry is a group of people who perform an important role in exchange for very little attention. They're the independent consultants, programmers, and designers who sell only their expertise. Jack Porterfield is one of these individuals who decided to leave the security of the corporation in exchange for his independence.
I just decided that I wanted to work on my own. The company, as I mentioned, had become large. It was small when I joined it. I like the intimate feel. I like informal. I guess the event was that I had quite a few friends who were consultants, and they sat there like sirens on the rocks beckoning, and I took the plunge.
Jack's office is now at home, and his living room houses some very sophisticated hardware. While he has managed to keep busy since choosing self-employment, Jack warns that consulting is not for timid souls.
The ability to take on a job, do it well, and make a client happy are really what it comes down to. In this business, if you have to show your resume, you don't have the job. You have to go in there and convince somebody on a one-to-one level that you can do the job, and then back that up with actually finishing the job and getting the product running.
The demand for independent consultants provides insight into how a computer company operates and why it needs to go outside for solutions to its problems.
Well, there are two reasons. One is technical competence, and the second has got to do with support. In the first case, they may not just be able to hire somebody, or they may not have anybody. And the second thing has to do with support. They may just need a particular job done once. Now, while it may appear on the surface that it's very expensive to hire me, that I'm only there for 2 or 3 weeks, and I get it up and running, and they never have to deal with this particular aspect of the business again.
Joining us now in the studio is James Patterson. James is coordinator of high-tech counseling at Stanford's Career Placement Center. And next to James is John Podkomorski, who is an R&D section manager at Hewlett-Packard and also helps out with some college recruiting at HP. Gary?
James, there's a recent study that was released by UCLA involving a few thousand incoming freshmen. And apparently the interest in going into the computer science degree program is less than it has been a few years back. What's the reason for that?
Well, I'm not sure, but I think what has happened is that even liberal arts students are finding that they can also obtain employment in the high-tech market just by taking a few courses in computer science. One does not necessarily totally have to have a degree in computer science and or EE in order to find employment in the high-tech industry.
So in a sense that computer science training has been really dissipated among a number of other
Yes,
disciplines.
you can find a music, for instance, major can get a job as assistant programmer as long as he or she has the courses that will allow them to do that particular work.
Mm-hmm. John, do you see that when you're doing your college recruiting?
We see a little of that. I think also there's a renaissance of attention into the business programs and the ability of people to make a contribution in computer science fields by going through business degrees and through MBAs and various other highly business-oriented functions. Mm-hmm. However, we continue to see a very high emphasis in the more technical computer science and engineering fields.
Well, this is actually a question for both. I'll start with John. When you go into a college situation to do recruiting, what do you actually look for in a student that's coming up?
We have several different types of requirements. For the R&D environment, we are obviously looking for very, very well qualified, very high GPA, strong technical contributors, often with technical backgrounds and the ability to demonstrate that they've worked in the field. We also recruit for classical MIS jobs, computer programmer jobs, computer technician jobs, computer repair jobs, a variety of different places, and they all have slightly different criteria depending on the nature of their needs.
Now, James, you're sort of, I'm sorry, James, you're sort of on the other side of it. Now, how do you prepare someone to say, talk to someone like John?
Well, basically, preparing, we want them to talk about their background and also give the employer an overview of some of the kinds of courses that they have completed to meet their particular need. Equally important, we talk with students about resume writing, job hunting technique skills, and also what's very important is communication skills. Being able to communicate to people, because no longer will that engineer be isolated by themselves, but he or she will be able to have to work along with other people in a group. So communication skills is very, very important, we're finding.
And this is one of their first opportunities to really communicate, right?
John, how competitive is it right now for the graduate coming out of school? I understand that you have your choice of 10, 20, 50 guys with a 4.0 average coming out for every job you have. Is that true?
Actually, for the competition coming out of high school, out of colleges, is very, very tough, particularly for degree programs, particularly if you want to come into some of the more major corporations, the IBMs, the Hewlett-Packards, the DECs of the world. And to give you a feel for that, on the campus that I recruit on, there's approximately 150 to 200 graduates every year, and we may hire 15 computer science graduates of that type. Everybody else finds jobs someplace else. Mm-hmm. And for those same 20 that are in the top 20% of the class, all of the companies are competing for the same group of people. And there's jobs for everyone. That's usually not an issue. But if you want to aim yourself towards one of the major companies, the focus is very intense.
Now, what is the example that you sort of alluded to this point that you go to a certain place to get a certain type of graduate? What schools, besides Stanford, of course, are the top schools that you go to look for, and what are the characteristics of the graduates that come from those schools?
Okay, I personally visit the University of Wisconsin in Madison.
Mm-hmm.
There are perhaps 20 schools within Hewlett-Packard Company that are targeted for college recruiting, among them being Champaign-Urbana in Illinois, Stanford, obviously, mm-hmm. Berkeley, MIT, all the names that you would expect if you listed the schools that seem like they have the most visibility and have good scientific and technical programs.
Now, John, if you are one of those graduates and you've got 20 guys and they all have 4.0s, what is that other thing you look for to decide which guy you're going to hire?
Communication skills, working background, experience, summer jobs, recommendations by faculty from time to time, their ability to demonstrate practical skills. So I don't care if someone does A's on their exam. What I want them to be able to do is to tell me about what they've done, mm-hmm. to have them explain to me that they really understand their work as opposed to just being able to demonstrate the mm-hmm. academics.
One of the things that you're bringing out here is that as an employer, sometimes I go into a situation like that and I look for a project, a good-sized project that a student has finished up, and they say, well, from beginning to end, It's actually a little bit of a work experience to
And
be able to do that.
do they understand how they did that
Right.
and why?
James, looking at the student side, as you counsel with Stanford graduates, what particular areas seem to be the hottest? What areas do students want to get into?
Right now, we're finding that there's a trend for, especially our EE students, to want to get into product marketing, customer support, and not just totally rely upon design. One of the advantages of the students in our area is that they can go to a broad spectrum of areas. For instance, not only just rely upon the semiconductor, but they can go into telecommunications, they can go to robotics, biomedical engineering, biotechnology, or some of the emerging fields that you'll find that our students are serving an interest. But more importantly, we're getting a lot of the engineers who are no longer saying, I just want to do design, I want to be able to work with people and be around with people, but I still want to use my technical expertise in a high-tech firm.
James, go ahead.
Just comment on that. I think that's really important because often in an academic environment, students are really bred and told that they must go into R&D because they're at the state of the art, and in fact, many fail because their personalities are ill-suited to that. And it's very important to start putting the emphasis now on where the right job is for your personality set.
And it's also a characteristic of our industry right now is that more and more people understand, the technical people understand that we need to have marketing and marketing people around and to support the work, because otherwise it's not going to be a success.
Well, even within the realm of R&D, we find that there are jobs that are working in new design, but the number of people that actually work in that area compared to the number of people that work in the sustenance of existing work, this is a very small number as opposed to the people that are necessary to keep things running.
Okay, gentlemen, thank you very much. We're out of time. Now, Gary and I, in just a minute, are going to go back online with that career network to find out what kinds of jobs are out there right now, so stay with us. Gary and I are hooked up again to this online career network, Gary, and we may be out of work soon, so maybe we better look for a job. Let's see what the opportunities are here.
Okay, well, I always wanted to be an electrical engineer. I always respected these guys. Let's try that.
Okay, so you can get an honest job here.
Okay, let's see if I'm qualified for this one.
Okay, what job are they looking for? A hardware test programming person. What are they looking for?
All right, we got microprocessor-based systems, so I qualify for that one, but looks like double E and CS background. Well, I got the CS background, so maybe I could qualify for that one. Okay. Except I don't think I'd probably be a very good electrical engineer based on my experience.
Okay, next job, a job in electronic packaging, and what do they require there?
All right, so then this is experience in design and packaging of computer system cabinets. I think I'll pass on that one.
Well, even there it says they want a BS, MS, or EE preferred.
That's right. Okay, how about let's try, I better get back into software, right?
Maybe we'll get
let's
you a
try
job in
software
software. Okay, you flunked on that one.
Okay, software development, number 4. Huh?
Okay, see if we can find you a job in number 4, software development. And what are they looking for here? Software
Again, this is only one company.
Yeah, this is Sperry. The jobs that are open at Sperry right now. Okay, here's a software development job.
Okay,
What do they want?
experience with the following software and hardware systems. Let's see what we got. I don't know what this 1100 OS experience is, but I can handle
I don't think you get the job.
The MASM PL1 Plus, Pascal, and C. I got that one, Z80. I can still remember some of that. How about Unix and MS-DOS? Well, I may have to paddle a bit on the MS-DOS. Okay, and again, this is one that requires, well, no, actually, it doesn't require any experience in or any educational experience. This is typical of the kind of thing that we see, let's say, when I'm doing hiring, I look at a strong educational base for one. If it's there, fine. If they haven't got too much experience, that's okay. Now, if you have a strong experience base, then it takes care of some of the educational parts of it.
So you can be a college dropout and still maybe get a job. Huh? Sure. Well, one of the nice things, in fact, in the computer field is jobs are being opened up not only in these higher levels, but at lower levels. For instance, one of the fastest growing areas is computer maintenance, where you can get a job maybe with just a couple of years of college. We're going to take a look at that now with this report from Wendy Woods.
9 out of 10 of these students will be able to walk out of this 2-year technical school into well-paying jobs in the computer industry. They're training in the fields of hardware, systems analysis, software programming, and maintenance. The Labor Department says these computer fields are among the fastest growing occupations in the U.S. through 1995, meaning the employment prospects for these students are virtually among the best for any profession in the country. Despite the slump of 1985, the careers for which these students are training have tremendous potential. While fewer will enter the manufacturing end compared to several years ago, more will walk directly into design and engineering jobs, especially in fields such as microwave and telecommunications, as America's electronics industry matures and specializes.
I think they have wonderful job opportunities in the field of electronic and computer technology, and whether it be from the design concept And the prototyping of new designs, the application to solving new problems through electronics and computer technology, to the manufacturing, quality control, installation, and servicing of electronic products ranging from medical to automotive to industrial to computing devices.
The students themselves, while admitting increasing enrollment in computer studies means increasing competition, are still optimistic.
The aspects look great. You know, the market was down, what, 3-4 months ago, but it is picking up today.
Enrollment in technical schools is generally increasing by 15% a year, while the number of jobs for these graduates outpaces that number. But the most important lesson they're all learning, meanwhile, is that their education won't end here. The fast-changing field of computers means a lifetime of learning, and many will be employed in specialties that we can only dream about by 1995. For the Computer Chronicles, I'm Wendy Woods.
We're back in the studio now, and joining us is Pat Hill-Hubbard, who's Vice President for Engineering and Technical Education at the American Electronics Association. And with us also is Harry Hamlin, the President of Hamlin Associates, a high-tech recruiting firm.
Pat, if I'm looking for a career in computers, what's a hot new area to go into?
I would say telecommunications is certainly a career that is here and tomorrow. In fact, we just did a small survey and we found that the projections for growth in software telecommunications areas just in 5 years is 2.5 times what it is today. So,
okay, and what's driving that?
I think it is, telecommunications is not singularly any longer AT&T's. It's a job that is of interest to all kinds of electronics and information technology companies, and not just here in the United States, but certainly worldwide. So we all need them.
Harry, how about you? What do you see as the hot new areas?
Well, definitely telecommunications, but overall, software is the language of high technology, and anybody who is proficient in software has a exciting life ahead of them.
So just a good basic computer science background would be a good thing to get into.
Absolutely.
Yeah, well, Pat, what about mentioning telecommunications? If you're a student in school now saying, okay, that's a hot area she told me about, what should I be taking? What should I be majoring in?
Well, that is a small problem today because AT&T used to train our telecommunications engineers, and they're not doing that anymore. In fact, we're just at the verge of launching a major new curriculum at the MS level in telecommunications engineering. But basically a combination of experience, I say a double E is the best preparation right now, and to hang tight, and maybe we'll be able to have a whole curriculum in the future.
Well, this brings up a point. Earlier we were talking about the fact that it's very easy to find a 4.0 student, a graduate. As an employer, I don't find that to be the case, that it's very difficult to find a real good engineer. How do we go about, as an employer, what's the best way to find these people? Harry?
That's what we're in business for. It's really a dedicated project to find these people. First of all, the employer must give us a very accurate specification as to exactly what he wants, and then we will spend from 30 to 90 days looking for that kind of a person.
Now, where do you find these candidates? Do you go into the colleges to find them? Do you go into companies to find them? Where do you actually locate these people?
The people that we search for are usually referred to us by other people. We do maintain a database by technologies and specific disciplines of people, and we approach them and the people that they know, and then go after them.
Now, doesn't this lead sometimes to, let's say, a kind of a checkerboard career that a person is moving? Well, we had this problem in the Valley, of course, of people moving from one job to the other. And if you're going in there pulling somebody out of one company, what's the effect on their career?
The life of a project, from product conception to the time of production, is 2 to 3 years or less now. It used to be 5 years, but now it's about 3 or 4 years. And when those projects are completed, an engineer is usually ready to proceed on to something else.
So an engineer should think of his career as being, say, segmented up into 6-year cycles or something? Would that be
Well,
the case?
that's not inconceivable. It's not unreasonable. He should set certain goals for himself to acquire new technologies. You don't want to keep doing the same job over and over again like happened recently in the disk drive industry.
So you're saying job changing is just part of the nature of
growth,
this career.
right, yes.
What about the geography of the opportunities? Are we just talking Silicon Valley, Pat, or where are the job opportunities?
Well, certainly they are here in our backyard, and certainly in California. I believe out of the top 10 areas, California has 4 or 5. And the whole Pacific Rim, if you will, is certainly a hot area. Oregon, Washington, Hawaii even, and Alaska. But, you know, it's certainly a national industry. Massachusetts, New York, I believe, is actually after California. Texas, Virginia is developing around the D.C. Beltway, North Carolina, the Research Triangle, and there's a new area called the Technology Crescent that's north of Atlanta, Georgia. So we are certainly, there are jobs everywhere in this country and abroad.
And if we take a look at also one factor is that we have these role models, Steve Wozniak, Steve Jobs, Bill Gates, various people who have dropped out of college to go into form their own companies. How important is that educational experience?
Well, I would like to say it's very important. I do believe it is. We're just not all there. We don't know where all of those Steve Jobs are. And the technology is becoming so complex that a very sound theoretical base combined with the idea that as you work, you seek out continuing education so that you don't become obsolete. That's an important thing to do.
What about the opportunities for women in the computer field? On one hand, we hear that it's a very open field for women, yet we hear there's still some biases at certain levels for women. What's your observation?
I would imagine there are biases. I would say women are certainly going into computer science. They do not seem to be going into computer engineering as much, or certainly not EE as much as some of us would like. One of the reasons, I believe, is that there are not role models in the classroom for them. There are very few female EE computer engineer professors, and even less minority.
Okay, real briefly, we have about 30 seconds. What about teaching? Isn't that a real problem that we don't have enough teachers to teach the students to get the jobs?
Yes, very much so. The national shortage on computer engineering faculty right now is 16%. That's in spite of the fact that the salaries are actually coming up. And in California, the need is enormous.
So there's certainly job opportunities in the teaching field. Thank you both very much. If you're interested, by the way, in more information about job opportunities in the computer field, we have some pamphlets we can send you. Write to this address, Jobs, care of Computer Chronicles at 1700 West Hillsdale Boulevard, San Mateo, California, 94402. Now, we've been talking about jobs that are being created by computers. Some people think computers are taking away jobs. We asked our commentator, George Morrow, for his thoughts.
It's not often one stumbles over a basic law of nature. Could it be I have? I want to call it the law of diminishing returns on complexity, and it goes like this. The labor burden of a machine increases in direct proportion to its complexity, while the labor benefit of a machine decreases in direct proportion to its complexity. Here's an example. If machine A is twice as complex as machine B, machine A will replace only half the labor force machine B did, while using twice as much labor to maintain, manufacture, and train for. Western civilization seems to have thrived on this principle, each generation creating more complex machines to support the increased population of the next. When it comes to complex machines, I think those of us in the microcomputer industry have done an outstanding job. In the repair and training fields alone, we may have created enough jobs to reduce national unemployment by half. It's a high watermark and may be hard to improve on. But then perhaps I'm underestimating our ability to make complex what could be simple. That's how I see it. I'm George Morrow.
In the Random Access File this week, Hewlett-Packard has joined the RISC battle, announcing its own new line of reduced instruction set computers. But HP says it has taken RISC technology beyond IBM, with many new engineering features that HP says will make its new computers faster and cheaper. Hewlett-Packard is calling its RISC technology HP Precision Architecture. The company said it is staking its future on the new technology, but don't rush out to buy one yet. The first machine won't be out until the fall, and the price tag is $225,000. The battle lines are already forming among computer scientists on RISC technology. Despite the new IBM RT-PC and the HP entry, some engineers are saying that RISC machines will be very difficult to write software for, and some are saying that RISC chips are less reliable, lacking adequate error checking and redundancy. Digital Equipment kicked off its big Deck World Bash in Boston last week by announcing a new local area network system called Deck Connect. It allows a single digital wall plug to accommodate 4 separate feeds, one for high-speed data, one for low-speed data, one for voice, and one for video. AT&T has announced a new low-priced email system with a minimum charge of 40 cents to send a one-page letter. A stamp costs 22 cents. AT&T also says it will offer delivered email to recipients without computers for as little as $7.50 for overnight delivery. It seemed like the Indy 500 of chip makers at the recent Solid-State Circuit Conference in Anaheim, California. Hitachi showed off its new Josephson Junction chip, which performed a calculation in mere trillionths of a second. NEC showed off its new RAM chip, which it said operated at 25 billionths of a second. AT&T demonstrated its new MOS chip, which it said moved data at 3 billion bits per second. And IBM said its experimental microprocessor has 93,000 transistors on the chip and can literally run a mainframe program on a desktop computer. Time for this week's software review, and here's Paul Schindler.
You know, some people are going to use one of these to look for Halley's Comet, but the rest of us are just going to have to try to peer into the sky for the big celestial event of 1986. If you want to see it early, though, it helps to have a sky chart. But sky charts have a problem. They really only show you roughly where celestial bodies are in the sky. Wouldn't it be nice if there was some way to obtain a sky chart that showed just what the sky looked like above your house? Well, as you've probably guessed, I know how to get a chart like that by using a package called PC Planetarium. Now, first it asks you for your latitude and longitude. If you don't know them, it draws a globe and asks you to point to your location. Note that the screen is colorful and the instructions are simple and easy to follow. When you complete a task, PC Planetarium says thank you, an often overlooked but pleasant touch. Then it asks for the time and date of your sky chart and what time zone you're in. Obviously ready for 1986, the program points out Halley's Comet as well as other celestial bodies and constellations. PC Planetarium is slow as the dickens. Takes 15 minutes to draw a screen and 20 minutes to print it. But heck, how often do you need a sky chart? PC Planetarium is $52 from Light Software in San Francisco. For the Computer Chronicles, I'm Paul Schindler.
In our legislative update file, the General Services Administration has just completed a survey of computer use by the federal government, looking at attitudes toward computers by new users. The most widespread applications, the big 3, led by spreadsheet analysis. The most frequently cited benefit was more timely output, and the biggest complaint, inadequate training. The Denver Public Library has developed a rather interesting computer application called the Electronic Atlas. Rather than struggling with the hundreds of pages in those oversized Atlas books, you can just enter certain database criteria and the computer will generate a map that answers your questions. There are 1,000 variables such as census figures, demographics, business locations, and so on. Finally, if you ever wondered how accurate barcode readers are, listen to this. International Robomation, which makes barcode readers, wanted to demonstrate the reliability of their system. They put a barcode on a Frisbee and threw it. And the barcode camera reader quickly and accurately read the data off the Frisbee. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.